Okay, so now we're going to go the other way. We're going to expand logs. So we're starting with problems that have the word log written only one time with no coefficients, no addition signs, no subtraction signs, and now we're going to expand them. So how do we know when we fully expanded something? We want to make sure that we have no more exponents, no more powers. We have no groups of more than one term. So in this first problem here, you can see that I have a 5, an x, and a y. So since I have 3 terms, the 5, the x, and the y, the number, the x, and the y, that means my final answer is going to have 3 logs. So I'm going to have the word log written 3 different times. I'm going to go ahead and break this up. I'm going to notice that I have 2 terms on top here being multiplied together. So I'm going to break that into log base 6 of 5 plus log base 6 of x cubed. So I've split up those two pieces using addition because those two pieces of 5 and the x cubed are being multiplied. Now, because this y here is division, that means I'm going to write subtraction, log base 6 of y. So now I do have the word log written 3 times, but I'm not done. I have to go ahead and get rid of this power. Now the exponent is only going to be a coefficient in front of the log that it's directly attached to. So it's only going to become a coefficient of just this piece right here. So finishing this problem off, log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. The only last thing I would do is I would look at any numerical logs, like right here, log base 6 of 5, where I don't have any variables. I would look at that and I would see, can I simplify that? Is that something that I can evaluate and I can make into a nice number like 1 or 0 or 1/2? And I can't, so I'm done. I have every log written with just one term. The 5, the x, and the y are all separated, and I have no more exponents. So looking at this next one, I have 4 terms. I have the 5, I have the x, I have the y, and I have the z. So 4 terms means I'm going to have 4 logs in my problem. Now these are all being multiplied together, so that means I'll have a problem entirely of addition. I'm going to go ahead and break this up as log base 3 of 5 plus log base 3 of x squared plus log base 3 of y cubed plus log base 3 of z. So I've now broken that up and written that as 4 different logs. I'm not quite done yet because I still have these exponents here. Remember, these exponents are only going to become coefficients of what they're directly in front of or what they're directly a part of. So log base 3 of x squared, this 2 is only going to become a coefficient of that term. And log base 3 of y cubed, this 3 is only going to become a coefficient of that one. So log base 3 of 5 plus 2 log base 3 of x plus 3 log base 3 of y plus log base 3 of z. Make sure that you write all of these log base 3's. Okay, those are important. Those are telling us that we have those like terms, that this is okay. My problem's done because I have a 5, an x, a y, and a z all in their own terms. I have no exponents left in my problem, so I'm good. I'm looking at this number one here, this numerical log, log base 3 of 5, and I can't evaluate that. That is not something that can evaluate, so my problem's done. Now let's look at example C. So in example C, I have 2 terms. I have the 2 and I have the x. So I suggest that this, 2 terms, first of all, let's write that down. 2 terms means I'm going to have 2 logs. I have 2 terms that are being multiplied, so I'm going to use addition. I would rewrite this radical x as a fraction exponent. The reason I'm going to do that is because I don't want to accidentally leave a radical in my problem. So when I go ahead and I take that radical x and I change it to x to the 1/2, now I clearly see that I have a power, so I don't want to leave that in my final answer, that radical, because that wouldn't be fully expanded. So I'm going to go ahead and break this up into the log base 4 of 2, that's one term, plus, because these are being multiplied, log base 4 of x to the 1/2. Now remember, we want to make sure that everything is fully expanded, so we've got to take this 1/2 and we've got to move that out to become a coefficient of that log base 4 of x. So I have log base 4 of 2 plus 1/2 log base 4 of x. Now, this is going to be the first time we have this numerical log here, log base 4 of 2. So let's think about that for a second. Log base 4 of 2. 4 to what power is 2? Well, think about, equating that would be 4 to the x equals 2. That's 2 to the 2x equals 2 to the first. 2x is going to equal 1. X is 1/2. You're going to get better at doing these in your head. So log base 4 of 2. I can kind of see, I know that I'm going to be able to simplify this because I can kind of see that the 4 and the 2, I can make those into the same base somehow. So if you need to go over here and do that work separately, or even type that in your calculator, which I'm about to show you how to do, you can do that to make sure that you're simplifying those logs if they can be done. So log base 4 of 2 is going to be 1/2. So I'm going to want to write this as 1/2 plus 1/2 log base 4 of x. Now these two 1/2s here, this 1/2 and 1/2, those are not something that you can add together. Those are not like terms. This is a 1/2, this is a 1/2 log base 4 of x. Two totally different things. The last problem here has three different terms. It has the 3, it has the square root of x cubed, and it has the 10. So the first thing I'm going to do is I'm going to rewrite this radical as a rational exponent. I think that's super important so that you don't accidentally miss something. So we'll change this into log base 3 of x cubed to the 1/2. So I'm going to take a baby step here real quick just to kind of prove a point, make sure everyone is on the same page with me. So that is really log base 10, okay, when there's no base there, it's a 10, of x to the 3/2 over 10. Okay, if you could simplify that 3 over 10, that would be legal. Like if that was 3 over 9, you could reduce that fraction. Since we can't do that, we're going to leave them both separately, and then we're going to treat them as three separate terms, the 3, the x, and the 10. So I'm going to go ahead and recognize that on top I have 3 times x to the 3/2. So I'm going to make that into log of 3 plus log of x to the 3/2. And I don't have to write any base here because there's no base written in my problem, but we're going to remember that that's really a log base 10. And then I have that divided by 10. So this divided by 10 right here, that's really telling me I need to subtract. So I'm going to have minus log 10. So now I'm going to go ahead and take care of this exponent because we can't have any exponents on our final answer. That's going to become the coefficient of the log x. So I'm going to have log 3 plus 3/2 log x minus log 10. Last thing you want to do is you want to look at those numerical logs. So here, log, there's really a 10 there, log base 10 of 3. Can I get a 10 and a 3 to match up somehow? No. But then when I look over here at this one, this is really a 10, they're already matching. So when the base matches what you're taking the log of, you have to remember that is really equal to 1. So my final answer will be log of 3 plus 3/2 log of x minus 1. I know that I'm done because I have log written just 2 times now because I've evaluated this piece right here, but I have no more exponents and I have no 2 terms in the same part. Okay, now the moment you've all been waiting for, and that's how to type these in your calculator. So I know way back when I told you your calculator will only evaluate log base 10, meaning your calculator will only evaluate something if you have, say, like log of 4, but your calculator is not going to evaluate log base 3 of 4. You have to know the special formula to type that in. So this is the change of base formula. I think there's a few special select calculators out there that will do this for you in the log base 3 of 4 format, but I know on your test we ask you to rewrite it using the change of base formula or rewriting it using common logs, so make sure you know this. So our formula says, okay, we've got log base b of some number. So the way to change that and write it in your calculator is by doing log of m divided by log of b. So this is written in terms of common logs because remember, base 10 is the common log. So I always like to kind of think like the base, drop the base, or put the base in the basement. However you need to think about it, whatever you need to do, just know the formula. So write each logarithm in terms of common logs, then evaluate to 4 decimal places. So writing it in terms of common logs is basically How are you going to type it in the calculator? So log base 9 of 27 means we're going to type log of 27 divided by log of 9. Now, you could evaluate this mentally because you can change a 9 and a 27 to have the same base, but let's see how we do this in our calculator. It says round to 4 decimal places. We'll only do that if that's necessary. When you type this in your calculator, listen up, people. You're going to press the button log. Log. And then you're going to see a parenthesis pop up. You got to press the 2 and 7 for the 27. And then this is the crucial piece right here. You've got to close that parenthesis before you put the division sign. And then log, another parenthesis is going to pop up. Put that 9 and close that parenthesis. Now, in all reality, this parenthesis is not as important, but this one right here, this is the golden child. If you forget that parenthesis, you're going to be all screwed up. So try it. Type it in your calculator. See, did you get the magic number of 1.5? Now, we're going to do all of these. Don't just take my word for it. You get out your calculator and you try this right now. So I'm going to write log base 2 of 35 as log of 35 divided by log of 2. Make sure you put that magic parenthesis in there, calculate that, and you should get 5.1293. Check it. Try it. Don't believe it. Maybe I'm lying to you. Now we'll try this one. Log of 1/2 divided by log of 12. Type in your calculator. See what you get. Negative 0.2789. Now think about this. Let's really try to understand the property of logs and how this works. This log base 2 of 35 is really telling us 2 to what power equals 35. You see how we got this positive answer? Positive answer, 2 to a positive number is going to make it grow bigger and get to be 35. Whereas if we look at this one, this is 12 to what power equals 1/2. In order to get a smaller number, we've got to change this. This is negative. So 12 to a negative number is going to become a fraction. Think about properties of exponents. This should be like, oh yeah, it makes so much sense. So if we think about this before we even start the problem, let's say we're going to have 32 to some power equals 8. How am I going to get a smaller number? Okay, well, log base 8 of 30, log base 8 divided by log of 32. That is a fraction number. Okay, now it's getting smaller. So that's going to give us a fraction, which is 0.6, a decimal. So notice the difference between when we got a negative, that's because we were turning a whole number into a fraction. Think about properties of exponents. That, 2 to the negative first power, 2 to a negative is going to turn that into a fraction. Whereas 4 to the 1/2 power is now going to change that 4 into a 2. It's going to make it smaller. So these are all just good observations that we can try to make to try to connect the dots between exponents and logs because they're so similar. Great job today, guys.